Today we're on pages 108 and 109 of our textbook. We're beginning Unit 4, which is logarithmic functions. Lesson 1 is an introduction to logarithms. It'd be good if you had your calculator and some colored pencils while viewing this video. Logarithms are the inverses of exponential functions. We have in exercise number 1, the function f of x equals 2 to the x is shown and graphed for us along with a table of values. The question is this function one-to-one? Does it pass the horizontal and vertical line tests? Yes, it does. Yes, it passes the horizontal line test. Based on our answer to part A, what must be true about the inverse of this function? Its inverse would be a function. Right? Recall, if a function is one-to-one, then its inverse is also a function. Create a table of values below for the inverse of f of x equals 2 to the x. We know that when we're looking at an inverse, we simply switch the domain and range. So if we want the inverse of x, I'll change colors here. Let me go with this. We take our domain from above, -3 to +3, and that is now our range. And our range is now our domain for our inverse. Now graph this by plotting these points. I find it helpful to have some numbers here. Okay. 1, 8, -3. So this is f inverse of x. Notice that, as always, the graphs of f of x and f inverse of x are symmetric across our line y equals x. What would be the first step to find an equation for the inverse algebraically? Well, the first thing to do is to switch x and y. If we have y equals 2 to the x, we switch x and y, and we have x equals 2 to the y. And now we need to solve for y. Well, how do we do that when y here is an exponent? We introduce logarithm. So the function y equals log base b, the subscript lowercase b, we read this as log base b of x, is the name we give to the inverse of y equals b to the x. For example, log base 2 of x is the inverse of y equals 2 to the x. Based on the exercise in number 1D, we can write the equivalent exponential equation for each logarithm as follows. Y equals log base b of x is the same as b to the y equals x. Looks confusing, but we'll we'll sort this out on the next page. A log gives as its output a y value. The exponent we must raise b to in order to produce the input x value. And let me just state here that when we have an exponential equation, like our y equals 2 to the x, right? We say that 2 is our base, x is our exponent, and y is our output or answer. When we switch to log form, we spell out the word base. We go log, subscript capital B, A, S, E. Now the S stands for equals, A stands for answer, E represents the exponent, and the capital B, base. And we'll work with this on the next page. So when we go from exponential form to log form, what's going to happen is the exponent is going to equal log base B of whatever the answer was. All right, and we'll get to that on the second section of this page. First, exercise number 2 asks us to evaluate the following logarithms. If needed, write an equivalent exponential equation. Do as many as possible without the use of a calculator. So logs give exponents as their output. So in other words, when we are asked to evaluate log base 2 of 8, we are looking for a base 2. What is the exponent on base 2 that gives us 8? What's the exponent? Well, 2 to what power is 8? 3. B, log base 4 of 16, is asking us 4 to what power? What's the exponent on 4 that results in 16? And that is 2. 4 squared is 16. C, log base 5 of 125, 5 to what exponent will give us 125? 3. D, log base 10 of 100,000, 10 to what power will give us 100,000? Let's see, there's 5 zeros, so that would be 5. Log base 6 of 136, 6 to what exponent? These are question marks that I'm writing there. 6 to what exponent will result in 136? And that is negative 2. Log base 2 of 1/16, 2 to what exponent would result in 1/16? Well, we know 2 to the power of 4 is 16, so negative 4. 5 to what exponent results in the square root of 5? Well, another way of writing square root of 5 is 5 to the 1/2. What's log base 3 of the 5th root of 9? 3 to what exponent would result in the 5th root of 9? And the 5th root of 9 we can also write as 9 to the 1/5, but recall 9 is equivalent to 3 squared. So the exponent would be 2/5. If the function y equals log base 2 of x plus 8 plus 9 was graphed in the coordinate plane, which of the following would represent its y-intercept? Well, we know for y-intercept, we substitute 0 in for x. So if we put 0 in there, log base 2 of 0 plus 8 is 8. What's the exponent on 2 that results in 8? That exponent would be 3. So evaluating log base 2 of 8 is 3. Log base 2 of 8 is 3. So 3 plus 9 is 12. Calculator use in logarithms. Most calculators only have 2 logarithms that they can evaluate directly. One of them is log base 10x. It's known as the common log, and is typically written without the base 10. So whenever you see log x, when there's no base, subscript base written, the base is 10. Evaluate each of the following using a calculator. Oh, what was the second one? The second one is the natural log, which we will see later on in this unit. So the common log is log base 10. Evaluate each of the following. I'm going to try it without a calculator. Oh, well, it says using a calculator. All right, without a calculator first for the first one. Log 100, that's the same as log base 10 of 100. What does that equal? Well, 10 to what power gives us 100? 2. On the calculator, where is the common log? It's right here. We would just key in. Both on the calculator. Come up a little bit. Log and 100 is 2. Log of 1/1000, 30, that looks like it'd be -3, right? 10 to the -3 would result in 1/1000. -3. And log square root of 10, we know that's the same as a half. There. .5, prefer the fraction 1/2. Okay, now here on this last section, this is where we want to go. We want to switch between exponential form and log form. Our exponential form, we have our base. Exponential form, we have our base to the exponent equals our answer. So I'm going to say capital B to exponent equals answer. To switch to log form, in log form we spell out the word log base. And again, the S stand is for equals. So the first one is done for us. 2 to the power of 3 is equal to 8, or 2 to the exponent 3 equals 8. So in log form, this is log base 2 of our answer, 8 equals 3. Oh yes, that's correct, because 3 is the exponent on 2, that would result in 8. Here, 2 to the power of 5 equals 32. Well, the exponent 5 is equal to log base 2 of 32. 5 to the 4th equals 625. 5 is our base, 4 is our exponent, and 625 is our answer. So log base 5 of the answer 625 equals the exponent 4. 6 to the power of 3 equals 216. 6 is our base, 3 is our exponent, 216 is our answer. Log base 6 of our answer 216 equals the exponent 3. 27 to the 1/3 equals 3. Our base is 27. Log base, this is subscript 27, of our answer 3 equals the exponent 1/3. R to the S equals T. Our base is R. Our exponent is S. Our answer is T. Log base R of T equals S. And the last one goes the other way. All right, it spells out log base, B-A-S-E. So our base is 4, our exponent is 3, equals 64, and that's correct. 4 to the power of 3 is 64. Now the other half, right-hand side here, we want to go from log form to exponential. It spells out base. Our base is 6, our exponent is 2, equals 36. Yes, 6 squared is 36. Log base 9 of 729 is 3. Our base is 9. Exponent 3 equals 729. Log base M of H equals P. Base M to the exponent P equals H. Log base 144 of 12 equals a half. Base is 144. Exponent 1/2 equals 12. And that's correct as well. And certainly you're welcome to pause and try the remaining ones on your own. But 144 to the 1/2, that's the same as square root. Square root of 144 is 12. Log base 10 of 0.001 equals -3. Our base is 10. This is base, answer, exponent. 10 to the exponent -3 equals 0.001. Log base B of 9 equals a half. Our base is B. Exponent 1/2 equals 9. And the last one, exponential form. 7 is our base. -2 is our exponent. And 1/49 is our answer. So we know we want to spell out log base. And this B, the base is a subscript, and S stands for equals. So this is equivalent to log subscript base 7 of 1/49 equals -2. Thank you very much for your attention.